Okay, thank you for your patience. Okay, so the last thing is rate of change problems. So all you have to recognize here is that we now, what you need to recognize now is that we know how to find derivatives. So now we can solve problems that involve rates of change in a lot faster way. The last time we did a real word problem that required you to find an instantaneous rate of change, you did it back in Unit 1 and you had to use this fun thing, right? Remember definition of derivative, right? You had to go through the whole process of finding a derivative the long way, and then it just so happened that that function represented a real life situation, and you used it to figure out to solve that problem back in Unit 1. So far in Unit 2, we focused more on the derivative rules on its own, so now we're looking at solving word problems using derivatives. So the finding of the rate of change function is going to be much faster. But it also means that we can have more complicated functions, right? Back in the first unit, it was very much, here's a quadratic, find a derivative, right? And you had to do the long way. Now it can be more complicated derivatives because we know the derivative rules. So, so very common problem, and here's the good news. I've already kind of done this problem with you already, the revenue problem. We're going to just do it again just to really solidify how it works. So a very common problem that will be examined is rates of change in business and economics. So there's several functions and derivatives you should be familiar with. So the demand function is the price function. It's the p at x, the lowercase p at x function. It's the price based on the number of units of a product or service x. Revenue function, capital R at x, is found by multiplying x times the price function. Okay? Product of the number of units of a product or service and the price. The cost function, total cost reducing x units of a product or service. Profit function, p at x, profit from the sale of x units of a product or service. And difference between the revenue and cost functions. So there's your different kind of repertoire or like vocabulary in terms of economics types of questions that would require you to analyze some, a real life situation involving a monetary scenario. And if you remember when we first learned this, remember that the starting point was going way, way back to grade 10. And do you remember when it was all based on the number of increases, right? And then we switched it to be in terms of x. So that's kind of what we're going to be doing here. So turns out that when we want to find derivatives of revenue, cost, and profit, we call it the marginal revenue, marginal cost, marginal profit. So anytime you see the word marginal, it means the derivative of revenue, the derivative of cost, the derivative of profit. So marginal, okay, and you see the word marginal, it means you're finding the instantaneous rate of change or the rate of change of the revenue, rate of change of the cost, rate of change of the profit. Okay, so let's do a question. A company sells 1,500 movie DVDs per month at $10 each. Okay. Market research has shown that sales will decrease by 125 DVDs per month for each 25-cent increase in price. So, determine the demand or price function. So, if you remember, we're pretty good at setting up this scenario in terms of number of increases, but then we're going to flip it so that we're actually working with number of items. Is this making sense? Is this kind of seeming familiar from? No, it's been a while since we did this. We did this back. If you look back at your notes from the product rule, we did this. Okay, I swear. But I'm going to do it again. This is why we're doing it a second time. So the first thing I want you to do is I want you to define a different letter, not x. We're going to define n. We're going to let n represent the number of 25-cent increases. Okay. So then, what ends up happening is, if you do let n be the number of 25-cent increases, and you want to come up with the, I know it's going to seem counterintuitive that we're doing this here, but if I want to come up with the revenue function in terms of the number of increases, right? Remember, the two things you multiply to come up with revenue is number of items times price per item. Okay, I'm going to write that underneath here. Number of items times price per item. Based on the fact that N is the number of 25-cent increases, okay, let's maybe go to the price part. So what would be your new price? What would be the price if you start increasing the price by 0.25? What would be an expression that represents, a general expression that represents the price of the item based on N increases? Beautiful. 10 plus 0.25N. Beautiful. And then the number of items based on N, because what happens as you increase the price, you start losing your 125 sales. So what would be your number of items expression? It would be, very good, 1500 minus 125. So right now, nothing seems unfamiliar. Hopefully nothing seems unfamiliar to you. This is grade 10. This is how you modeled it in grade 10. But then you were basing, you guys get the variables all wrong here for this question though. We don't want to be worrying about this number of increases. We want to just be able to input number of items, output price. So this is what we want to do. Okay, instead of working with this, I want you to let X, okay, represent the number of items. Well, do we have an expression for X then? If X is the number of items, is number of items already on the board here? In terms of N's. Is there any expression on the board here that has number of items also? This first part here, right? The number of items will 1500 minus 125N. So do you all agree that X would equal 1500 minus 125N? Yeah? Okay. Why is this going to help us? If you, do you guys, you just created a form, it's like, think of like a formula that relates X's to N's. Could we then use this relationship to get the price per item to be in terms of X's instead of N's? Here's my equivalency. I know that X equals this. Could I get what N equals here? Could I isolate for N here? If I have 125N equals 1500 minus X. And if I 1500 divided by 120. So N equals 1500 minus X all over 125. That's kind of yucky. If you divide 125 by both of these pieces, 1,500 divided by 125 is 12. 1 divided by 125 is 0.008. So that's N. You now have N in terms of X. Okay. So N's in terms of X. Could I now find the price per item, this expression right here, in terms of X's? If I now know I can replace N with this, right? So the demand function, okay, demand function P at X is going to be 10 plus 0.25, and then I'm going to replace N with 12 minus 0.008X. Okay, and just becomes a little distributive property right here. 0.25 times 12 is 3. 0.25 times 0.008 is 0.002. Okay, so I got negative 0.002x plus 13. So all of this work to get that. This is the hard. This has nothing to do with calculus, and it's the hardest part of the question. Okay? But that's how you get a demand function if they ever ask for it. Now, if you guys get that, I can make life a lot easier for you. Okay? And basically just say the demand function. If I said the demand, instead of me giving you the information like this, I could say the demand function is this. I could just give this to you. Okay, but this is how you get it if it's not given to you. Okay, great. So now let's move on to part B. It says determine the marginal revenue when sales are 1,000 DVDs per month. So there's my demand function. Before I can find marginal revenue, I need the revenue function. And this is the key, guys. Revenue function. The revenue function is X times the demand function. Remember, it's still number of items times price per item. And you have just turned number of items. You turn number of items into X. Here's your number of items, right? Your price per item is this. We just changed the variable, but it's the same relationship. So my revenue function is going to be X times the demand function, so negative 0.002x plus 13. There's my demand function times the price, times the number of items, so that's your revenue. Okay. Now, I'm not going to force you to do product rule here if you don't want to. Would it just be simple enough to distribute that x? So let's distribute it. Negative 0.002x squared plus 13x. You guys get that everything else here is going to be golden and easy. So if I want marginal revenue when sales are 1,000, there's my revenue function. What do I just need to do to find the marginal revenue? Derivative. Marginal means derivative. So find the derivative. An easy enough derivative to find here, guys. Negative 0.002x squared is negative 0.004x. And the derivative of 13x is 13. Can I find the marginal revenue when sales are 1,000? I want R prime at 1,000. Plug in shout. Now, here's something I will be super picky about. What are the units of your answer here? And this is the reason why we went through this whole ugliness, is to make this part make the most sense if you work in business, right? The model, like, probably this is the information you would understand from market research, like you get this information. But to actually be useful, we'd like to do the switch over to being in terms of X, because now this actually should make sense, because now this is telling me that when I sell 1,000 DVDs, my revenue is doing what here? My revenue, this is the rate of change of revenue, increasing at a rate of $9 per DVD. Do you guys get that's a useful piece of information if I work in business? If I say dollar amount per 25-cent increase, that's like, how do I use that? That's weird. But I know, oh, so if I sell that many DVDs, I make that much per DVD. Like that's a more logical, useful piece of information, okay, if I'm working in business. So that's perfect, okay? And again, what does this mean? So it means that when I'm selling 1,000 DVDs, okay, my revenue is increasing at a rate of $9 per DVD. Okay. So part C, okay, I think we need to maybe call it a day. It's 11:11. So hopefully that part doesn't seem too shocking. If you go back, we did an example of this in 2.3. So if you wanted to like go back through your notes, sorry, 2.2, we did an example of this if you wanted to refresh your memory. But tonight you're just working on the 2.3 homework, okay guys? Thank you.